Hello everyone. In the last session, we have seen how the memory will be allocated to the structure members, and also we discussed how to use an array of structures and pointer to a structure. And we have seen how to access the members of a structure by using pointer. In the same session, we also discussed what do you mean by the designated initialization. We discussed that it is the initialization in which we can assign the elements to the structure members in any order. In today's session, we are going to discuss the importance of type def statement. After that, we are going to see how to use an array of pointers to a structure. After that, we are going to see some of the important gate examination questions on structures. After that, we go for the practical implementation of programs using structures by Visual Studio Code. Now, first, let us go to the statement type def statement. What do you mean by the type def statement? Its abbreviation is type definition. We write it as the type definition. What do you mean by the type definition? See, for example, we know the primitive data types. Primitive data types, or we can say built-in data types. As we discussed in the previous classes, int is the primitive data type, right? So, can you give your own name for the existing data type int? For example, I want to use int as my int. So my int is not an existing data type, but we want to give my own name or user defined name to the existing data type or built-in data type, that is primitive data type int. Is it possible? It is possible by using type definition statement. How to write? So first we are writing the statement type definition, and you write existing data type, and here you write your own user defined type. So this is the way of using type def statement. Now, in the next statement, whenever we want to declare a variable of type integer, for example, we want to declare a is of type int, but don't write int, you can write directly my int. So it is the new name, but its internal meaning is int. So this is the way of using the type def statement. The syntax for type def statement here is you write first type definition, and here you mention any primitive data type. After that, you give some space, and here you mention user defined type. This is the use of type def statement. Now, the main use of type def statement in structures we are going to discuss. See, generally, whenever we want to declare a structure, we write the structure like this struct and assume that the name of the structure we are saying book, and here we are taking some field names, character b name, and we have given some dimension 20, and here we are writing integer pages, and here float marks semicolon, here right we are writing semicolon. This is the way of declaring a structure, right? So inside the main, if you want to declare a variable or structured variable, so every time we have to mention struct book, and here we have to create a structured variables like b1 and b2. Every time we have to say struct book. Now, is it possible to give the new name for the data type struct book? Like we discussed previously, so before struct book, just you write type def, space struct book, and before this semicolon, you do one thing, just you write book and semicolon. When you write type def struct book, and after this, after closing brace, if you write book semicolon, what is the meaning of this? See here, the data type, the user defined data type or user defined structured data type is struct book. This is the user defined data type struct book. Now we are renaming the user defined data type struct book as book. Now whenever we write struct book, in the place of struct book, directly you can write only book b1 comma b2. So this is the way of using the type def statement So the use of typedef statement is, so here instead of writing every time struct book, we can give a shortcut name like book. So the meaning of book here is every time struct book. See, just now we discussed that for the built-in data type int, we have given myInt. Now, in this case, the data type for the data type struct book, we are giving another name called book. Book is the shortcut for the data type, user-defined data type struct book. So that is the way of using typedef statement. So to give shortcut names for the user-defined variables or the user-defined data types or built-in data types, you have to use the concept of typedef. Now, after that, we are going to discuss an array of pointers to a structure. What do you mean by array of pointers to a structure? For example, if I write struct student, and here if we write some character name of the student, and here we are taking the size or dimension 10, and you take integer rule number, and here float, every time we are taking the same example marks, and here after closing brace, what I'm going to write here is I'm writing star s of 5. Here I'm writing like this. What do you mean by star s of 5? When we write star and square brackets, first the precedence is given to the square brackets, right? First precedence will be given to the square brackets, and next second precedence will be given to the star operator. Now star of s of 5 meaning is s of 5. First you take s of 5, means it is an array. Array of how many locations? 5 locations. 1, 2, 3, 4, and this is the fifth one. Now first one is represented as s of 0, and this is s of 1, and this is s of 2, and this is s of 3, and this is s of 4. Now each memory location is a pointer. First we are taking array of 5 elements, and each element is a pointer. Pointer to how many data members? 3 data members. The first data member is name, and second one is rule number, and third one is marks. Same, it is also going to point to the same 3 members, and it is also pointed to the same 3 data members, right? Now it is also pointed to the 3 data members. This is the way of accessing the elements by using array of pointers. How to access this first element name by using s of 0? As we discussed, first you write s of 0 and you write arrow operator, arrow of name, or pointer to member operators name. See, previously when we use the concept of arrays, just we said s of 0 dot name, but we are not writing s of 0 dot name. Instead of writing s of 0 dot name, we are writing it as s of 0 arrow operator, means pointer to member name. Why? Because s of 0 here is a pointer, whereas in this case s of 0 is only the first location. It's not a pointer. S of 0 simply consists of the address, but here S of 0 itself an address, but here S of 0 is a pointer which consists of address. So in the previous classes we discussed that S of 0 of name is same as, I said, S of 0 star of S of 0 dot name, that we have already discussed. So this is the way of accessing the elements of a structure, the members of a structure, by using pointers. Now after this, we are going to see some important gate examination questions. Let us discuss what is the output of this gate question. This is very important question on pointers. Now you see here, the name of the structure here is point. Okay, now how many data members are there? X, Y, Z. The data members are here X, this is X, and this is Y, and this is Z. Now until unless a structured variable P1 is created, the memory is not allocated. Okay, whenever the structured variable P1 is created, now memory is allocated, right? Now dot y equals to 2 and dot z equals to 0 and dot x equals to 1. This already we discussed. It is a designated definition or initialization. Now, dot y in the sense p1 dot y, how much? This is 2. Next, dot z means p1 dot z, how much? 0. Now, x equals to 1. Dot x means the first item. See, in any order, we can assign the values, right? Now, here the important thing here you have to use is what is the variable here? P1. P1 is the structured variable. Now, assume that the address of the first location is 100 and the address of the second location is 104 and this is 198. Why? Because every integer is going to take 4 bytes. Now, what P1, the structured variable P1 contains? P1 itself represent the address 100, like an array name. When you declare an array name A or array name itself represent the base address. In the similar way, now P1 represents P1 itself. P1 is not a variable which stores address 100. No, P1 itself an address. That is very, very important. Now, for example, if you create a pointer struct point star P, and if you say P is equals to star ampersand of P1, its meaning is different. In this case, we have to say that P is a variable which stores address of P1 means how much? 100. So here it is pointing to this. The meaning of this star P and here it is P1 is different. P1 itself represents address. Means it's representing the base address of this. Okay, base address. Now, when we say printf percentage %d and p1 dot x, what is the p1 dot x value? 1. Next p1 dot y, how much? 2. P1 dot z, 0. We are going to get the output of this is as 1, 2, 0. After this, the next gate question is like this. Here we have again x, y, z variables. Okay. Here we are writing x, y, z. This is x and this is y and this is z. We are creating a structured variable p1. Okay. P1 is the structured variable. Now we know that, assume that the address of the first location is 1000 and the address of the second location is 1001 and this is 1002. Very, very important thing is the address of the first location is 1000. Right? Now, if you treat these 3 locations as whole, the address of the entire, so here P1 points to the base address 1000, right? Now, the address of P1 is again assume that it is 1000. Now, here the important thing you have to remember, this 1000 is different. This outer 1000 represents the address of the whole structure, right? Now, the address of the whole structure is same as the address of the first element. Now, P1 represents the address of the first element, whereas we have a pointer called Q, whereas Q represents a pointer which consists of 1000. This 1000 represents the address of the whole structure. That is very, very important. Simply remember, P1 points to internal 1000 and Q points to external or outer 1000. Now, here we are storing the address Q. Now, printf percentage %d percentage %d. So, before printing these values, so let us go for this. Now, first you take Q. Q value how much? 1000, outer 1000. Now, after Q, now you apply character star. Actually, when you consider this internal 1000, this means that it is the internal pointer to a character 1. This 1001 is the internal pointer to a character 0. And 1002 is an internal pointer to A. A means ASCII value of A is 97. 97 plus 2, 99. 99, its ASCII value is 99. Its corresponding character is C, small c. So the values of the locations are 1 in single quotes, 0 in single quotes, C in single quotes. Okay. Now first Q represents this outer 1000. Now, from this outer 1000, we have to move to the inner 1000, where inner 1000 is a pointer to character 1. So, that's why we are taking this outer 1000 and we are converting into a character pointer. Why? Because you have to change this 1000 to this 1000, where internal 1000 points to, or it is a pointer to a character. So, here we need typecasting. So, that's why we are converting ordinary outer 1000 into internal 1000, which is a pointer to character. So that's why we are taking this character star typecasting. Okay, now we are moving to this 1000 internal 1000 location. After that, you perform the operation plus 1. Plus 1 means we are moving to the next location 1001. Okay, after moving 1001, now you apply this star of internal 1000, star of internal 1000. Internal 1000 is the character to this 0. Now star at 1001, how much? We are going to print this character, so we are going to get 0. Now next, character star q plus 2. Plus 2 means we are moving to the next location. Q is 1000. 1000 plus 2 means first we are taking 1000. Okay, 1000 we are converting into character pointer. Now we are moving to this again. Now plus 2. Plus 2 means here to here. Two locations you have to move forward. After that, we are applying star of 1002. So here we are going to get C, but we are printing using percentage %C. So we are going to get 0 and C. We are not going to get 0 C in single quotes. Why? Because they are stored internally as character, but at the time of displaying, we are getting output 0 C. This is the output of this question. After this, we will see how to execute the programs using structures, or how to implement all the programs that we have discussed earlier using Visual Studio Code practically, that we will see. Now we will see how to write programs or how to implement structures using Visual Studio Code. Let us go to the new program, and here you give the file name structures.c. Now here we are going to write the first program using structures. Till now we didn't write any program using structures. We have explained everything theoretically, but practically not yet done anything, right? Now we know the first statement. Here we write hash include stdio dot h. Okay. Now after this, so as per the previous classes, we are going to define the structure in the global scope, right? In the global scope, we can create a structure. In the local scope, we can create a structure, but we prefer the global scope, right? Now we know that the keyword you have to use is struct, and here the name of the structure, as I mentioned earlier, is optional. Struct and structure name is there, but the name of the structure is also called structure tag, but the name of the structure is optional. So first I am writing the structure without any structure tag, and after that I will explain what is the main importance of using structure tag. Now struct, and we are giving some field names. Assume that character, I'm writing student name. This is the first field I'm taking, and here integer rule number, and here you take another data member float marks. And we know the structure ends with a semicolon. But before the semicolon, I'm going to write the structured variable s here. Now, the name of the structure is here, not there, but the structured variable here is s. When the structured variable s is created, then the amount of memory allocated for s is 10 bytes plus 4 bytes plus 4 bytes. Total how much? 18 bytes. But only we get 18 bytes when we use the concept of hash pragma. Until unless you don't mention hash pragma, you are going to get 20 bytes. Why? Because already we discussed in theoretical part. So extra 2 bytes padding will be done. 18 plus 2, so 20. That we are going to print when you print the size of the structured variable s. Okay, here we have created a structured variable s. Now next we are writing integer main, opening brace. Here what I'm going to do is I'm going to assign the values to s. Now how to assign the values here? See, if you say s directly, we can't say s equals to. Now what you do is again you have to mention the structure, you have to define this structure in the local scope. Or instead of writing like this, you do one thing. So before semicolon here, you can assign the values. Here I am writing the values, opening brace, student name you give Anil, right? Some name we are giving. Here you can initialize the values. Rule number you are giving 100, and the mass we are giving is 3345.65. So here before the main, here I'm initializing the values Anil 100, right? Now you can ask one doubt. If you want to define within the main, if you want to initialize within the main, what you do is again you have to write the entire structure once again, and you have to write the variables you have to initialize. Here if you say, for example, here what you say is struct, there you have initialized the variable s. Now what you do is, for example, here you have given the values Anil and 100. Now you print the values first printf, and you give first one is percentage %s, second one is percentage %d, third one is percentage %f, and here slash n. Now here you print first one is s dot s name, s dot s name, comma, next s dot rule number, comma, s dot marks. Right, this is the way of printing the elements. Okay, final statement we know written 0. Let us try to execute this, whether we are going to get the correct output or not. Right, we are getting Anil. Okay, Anil, after that 100 and 345.64. Okay, so the remaining digits we are getting some values. Okay, that we will see s dot marks. So better to write slash n here, slash n. Here also you write slash n. Now you save it once again. Now you run this. 345.65. So instead of printing 65, it is printing dot 64.9994. Okay, exact value it is not printing, it is printing the approximate value. So this is the way of assigning the values here. Now you can ask one doubt, sir, is it possible to give the values in the main? For example, instead of giving the values here, I want to initialize the values here. Now what you do is, again here you have to say struct, or you can say, can you say, for example, you try to say s equals to, for example, first one you give the name, just you try what happens, and you give the value 100, and you give another one 203.65. So what it is going to see, we will see. If I write this, we will get an error or not, that we will see. See here, error. Why? See, in the local scope, we are trying to use the variable s, but you have not created this. Now what you do is you remove s here. Now here you say struct yes. Here you have to say struct yes. Whenever you say s here, you only initialize the values there. Whenever we say here inside the main, this comes under the local scope. This comes under, whenever you declare here, this comes under the global scope, and this comes under the local scope, right? Here, this is the different way to initialize the values in using local scope. Previously, we have seen scope going for local scope. See here, when you are trying to write this, it is going to give an error. Right, why it is giving the error? See here, why it is giving the error, we are not going to get the answer. Okay, now the problem here is whenever we are trying to create a structured variable in the local scope without using structured tag, we are getting this problem. Now, what you have to do here is, here again you have to mention struct. See here, you have to mention this control C, and here you have to mention control V. Here you have to say like this, right? Though it is a local scope, if you create only ordinary S, it is not going to give the correct answer. Now you check it. Here we are going to get the output. What is the problem here? See, I think the problem you have identified. What is the problem you have identified? Can you tell me? The problem here is, see, whenever we declare a structure or a structured variable without structured tag, so when we try to use that structured variable within the main, every time you have to define the structure once again. Okay, it doesn't know what is S. Okay, now here we have structure, global scope we have structure, in the local scope we have structure. Means whenever we try to use the structured variable within the main or local scope, again it is asking what is the type of the structure. See here, we have not mentioned the type of the structure here. That's the problem. So this is the problem we are going to get whenever there is no structure tag. For example, if you have a structure tag like a student here, then what happened is, though you didn't say here variable as, here in this, just you have to say, the thing here you have to say is struct. You can't say struct S. Here you have to mention the type of the structure. Here you have the structure tag student, yes. See, if there is no structure tag, again you have to define that structure here. That's the problem. Now we see what happened. Right, we are getting the output. So this is the importance of using structure tag. In the next class, we will see more examples. Now, how to use pointer to a structure, how to use an array of structures, and how to use an array of pointers to access the members of a structure. So here, what we have identified is we can create a structure without structure tag. The problem without using structure tag here is we are going to get the problem of redundancy. Means whenever we want to use a structured variable within the local scope, every time you have to create the entire skeleton or structure or template. That's the problem. So previously we have done the structured template before the main, but when we try to use the variable of that type, again we are writing the same structure in the local scope. So that is the major drawback of not using structured tag. So to overcome the redundancy, better to use the structure name or the structure tag. So in the next class, we will see more practical examples. With this, I'm going to close the session. Thank you for watching.